Radicals and variables? Oh my! There's actually not a whole bunch that's super scary about radicals and variables, but it's just worth taking a few moments just to do a little bit of an example. If I would ask you to simplify, it's not going to be helpful if I write in highlighters. If I ask you to simplify and I give you something like this one, if I were to say give you the square root of x to the power of 3, what I want you to first do is get it into digestible chunks. So if I were to say the square root, and you guys know I don't have to put that as my index, it's just implied, I would say the square root of x squared times x, because using our exponent laws, x squared times x is x cubed. And then I'm going to separate them out here. So the square root of x squared times the square root of x. The square root of x squared is the absolute value of x. And there's nothing I can do with this one, so I just say root x. Now, that looks so wrong. I know. Trust me, I know. But this is actually the correct answer. What happens if I would give you another one? What happens if I give you one that looked like this? The square root of x to the 5. Same principle. I would say the square root of x squared times the square root of x squared times the square root of x, because x squared times x is x to the power of 5, so we can do that kind of little check. Actually, what I want to do is I don't want to quite separate them out yet. So x squared times x is x to the 5. Now we can separate them out. And you could have done this in the first step. It's just easier to see this way. See it a little bit more transitional. So I'm saying that the absolute value of x times, now the square root of x squared is the absolute value of x, times root x. Now if you have the absolute value of x times the absolute value of x, I can just say that that is simply x squared times root x. Why? Well, let me just do a little side work. You don't have to write this down or anything. But if I were to say negative 5 times negative 5, I'm going to say that that is 5 times 5, or let's do it in brackets here, 5 times 5, which is 25. So no matter what my original x is, positive or negative, I end up with something that's positive. So that is the reason why I can simply say x squared, because it doesn't matter if x is negative or x is positive. Even if we take the absolute value of a negative number and square it, it's always going to be positive. So this is good. What if we have this c here, and if I'm looking at cubed roots, I'm going to say p to the power of 7. So I'm just going to break it up into now sections that are digestible with cubed roots. So I'm going to say p to the 3 times p to the 3 times, the cubed root of that, times p, because 3 plus 3 plus 1, which is the implied which is not the index, the implied exponent here, I'm going to get p to the 7, so I can do that quick. So that is the cubed root of p times p to the 3 times the cubed root of p to the 3 times the cubed root of p. Well, I have here, this is p, times this one right here, which is p, times the cubed root of p. I can't simplify this one down anymore. I can say that the cubed root of 2 to the 3 is 2, right? The cubed root of 8 is 2. So I can simplify these ones, but this one you can't simplify. But I can simplify this a little bit more. I can say p squared times the cubed root of p, just like that. So you're going to see some variables in some of the exercises that we're doing. I just don't want you to be too nervous about them because they're pretty easy to simplify. So now let's look at this work here. So turning an entire radical into a mixed radical when the index is 2 or implied 2. Okay, and then we're going to say when the index is higher than 2. So I'm just going to give an example here. Square root of 75. So step 1, break into perfect square factors. Products of, break into products. Yeah, I'm going to say that. Of perfect square factors. And then 2, don't skip a step, to simplify where you can. And that's it. Okay, so I'm looking at the largest perfect square factor here. I'm going to say, 75 is simply 3, or I'm going to put the perfect square factor first because it's easier for me to say, or easier for me to see. So 25 times 3. I'm going to break it up. Root of 25 times the root of 3, which is 5 root 3. What happens if I say something like the square root of 32? What I want you to do is, yeah, I can say this. I can say, oh yeah, okay, 4 times 8, which is going to be square root of 4 times the square root of 8, which is going to be 2 root 8. But we still have a factor of 4 that's embedded in there. So what you want to do is you want to find the biggest square root factor. The biggest square root factor of 32 is going to be 16 times 2. And then I'm going to break this up to 16 times the square root of 2, which is 4 root 2. Now what I could have done in the other one, I say 2 root 8, I can break that down. I can say, okay, 2 times root 4 times 2, which is 2 times the square root of 4 times root 2. When I say root 2 or square root of 2, I'm saying the same thing. 2 times 2 times root 2, which is 4 root 2. So you see, we come up with the same answer. It's just that this one is more desirable because it's way faster. So I'm just going to erase this one because it's not super necessary. I'm going to do one more here. I'm going to say the square root of 8 times x to the power of 3. Now a lot is going on here. First we need to break into perfect square root factors or perfect square factors in the 8, and then we need to break it up into the perfect square factors of the x to the 3. So if I were to say 8 is 4 times 2 times x squared times x. So what I'm going to do is I'm just going to break it up and pull these guys out first because they're going to become the coefficient. So root 4 times root of x squared times root, and since these ones are the ones that are going to turn be simplifiable, root 2 you can't simplify, and root x you can't, so I'm just going to keep that under one radical sign. The square root of 4 is 2. The square root of x squared is the absolute value of x, and we're left with 2x. That might make your head spin a little bit and you're like, that's not a real answer, but I'm going to comfort you and say, yes, it is a real answer, and that's what the answer is. We're gonna get to why the absolute value is a little bit of an overkill in the next lesson, like a little bit overkill. Sneak preview is that x has to be greater than 0 or it has to be positive, because you can't have a negative sign under a square root. You can have a negative sign under a cubed root, but not in a square root. But that's a sneak preview. You don't have to understand. I'll explain that tomorrow, or the next during the next lesson. Okay, well, what happens if you have when the index is higher than 2? So what happens if I have the cubed root of 54? Well, the same principles abound, right? So you want to find, so break into products of perfect, I'm just going to say boop, or like fill in the blank factors, because it might be a 3, it might be a 4, it might be a 5. Okay, and then 2, simplify. So I'm going to break it up into perfect cube factors. So the cubed root of 27 times 2. So then I'm going to say, okay, so the cubed root of 27 times the cubed root of 2. Can't simplify here. Sorry, that's if it's opposite day. I can't simplify this one, but I can simplify this one. The cubed root of 27 is simply 3, because 3 times 3 times 3 is 27. And then I say cubed root of 2, just like that. And that's my final answer. I'm going to put a box around it because I like my teacher. So I've given you a few things to do. I've given you some textbook questions, so please refer to that sheet of paper that I gave you, letting you know where all the practice was. So I gave you some textbook questions that get you to practice the the principal square root. So a lot of this business here. And then I gave you 2 worksheets, some which are simplifying radicals when the index is 2, and then some of them are simplifying radicals and turning entire radicals into a mixed radical when the index is higher than 2. So have fun!